All right, so we're going to solve this trig equation, and we're going to solve it from 0 to 2 pi. We're going to include 0, right? We're not going to include 2 pi. So we have a very specific domain in which we're trying to solve this particular problem. So taking a look at this, right? 2 cosine squared of x plus 3 cosine x plus 1 equals 0. We have not seen one like this before. So what looks different about, ooh, we're going to get there. We're going to get there. What looks different about it? It has a squared. Very good. What else?
It's all on the same side.
Yeah, so all of you are mentioning it looks like a quadratic. And you are 100% correct. It looks like quadratic. Imagine for a minute that the cosine was just representative of the variable x. We'd have 2x squared plus a 3x plus 1, right?
Yeah.
So we can do the same tricks that we do to solving quadratics with algebra with this as well, okay? But before we get there, it's always good to know how many solutions we're looking for. So what are we going to do first? We're going to graph it. So bust out those calculators. Awesome. Here we go. Okay. Here we go. Here's my calculator. And I'm ready to go. So I'm going to punch in the left-hand side. I'm going to punch in 2.
Do you have to be in a certain radian or degree for this?
Whenever you're graphing a trig function, it needs to be in radian mode. So we got 2 cosine x, close parentheses, then squared. That's how you punch in a squared on this calculator. On the newer ones, you might actually be able to put the squared right where it looks where you write it. Okay. Then I'm going to add 3 cosine x, excuse me. All right. Then finally, I'm going to add 1. Now, that's the left-hand side of my equation. The right-hand side is 0, and I told you in the last lesson we graphed the left and the right-hand side. But if I just graph the line y equals 0, what line am I graphing? Anybody know? A horizontal line called the x-axis. So basically, we want to know, when does this equation cross the x-axis? That's what we're looking for, okay? Now, because we have a very specific domain, namely 0 to 2 pi, we're going to make our window match our domain, okay? So we are going to go from 0 to 2 pi. That's what this is. My lowest max is x is 0. My highest is 2 pi. My scale, I'm going to go in terms of the quadrants. So I'm going to go in terms of pi over 2s. Okay, so pi over 2, pi, 3 pi over 2, and then all the way back around 2 pi. Now, my y minimum and maximum, I'm curious as to where this graph crosses the x-axis. So I don't need to be down there at -10 and up there at +10. I might as well just focus in around the x-axis, okay? So it's important that you guys understand the concept of the window and how to set it up. You guys on board?
Yes.
Okay, now that we have our window set up and we have our equations plugged in, we're going to hit graph. Ooh, look at that. Looks like a W. Okay, that's what you should get. So guys, how many solutions are we looking for then from this?
2.
No, try again. 3. We're looking for 3. Check it out. There's 1 here, there's 1 there, and there's 1 there. And it looks like, you guys, because our scale is pi over 2s, so every little tick mark here is a pi over 2. So 1 pi over 2, pi, 3 pi over 2, and then 2 pi. It looks like pi is going to be one of the solutions for us, okay? So we're looking for a grand total of 3 things. That's good to know. I'm going to write that down over here. We're looking for 3 solutions. Yay, we're looking for 3 solutions. Good to know. All right? So how do we go about getting them? Well, you were all alluding to the fact, a nice word, right? You guys were all alluding to the fact that you could factor this thing and you would be totally right. So how could we try and factor this? How could I factor 2 cosine squared x?
2 cosine x?
Yeah, 2 cosine x times cosine x. That would give me a 2 cosine squared x, right?
Then it has to be +1.
Very good. Seth's on it, right? The last term is a 1. The only way to factor a 1 is a 1 and a 1. And everything's positive. So positive and positive. So just to prove to you that this indeed is true, watch me do FOIL, right? If I do first, what do I get? I get a 2 cosine squared x, right? Outer, I get a plus 2 cosine x. Inner, plus a cosine x. And then finally last, plus a 1. Well, check this out. Those are always like terms. Look what we get. 2 cosine squared x plus a 3 cosine x plus a 1, which is what we have right there. You guys on board with that? All right, very cool. So I'm going to go ahead and rewrite the factored form right down here. We said it was 2 cosine x plus 1 and a cosine x plus 1 equals 0. So now, what did you do before when you were factoring quadratic x? Yeah, each term. You use the zero product property, right? So therefore, 2 cosine x plus 1 is 0, or cosine x plus 1 is 0. Using the zero product, product property. There we go. The zero product property. So therefore, solving this one, I'm getting cosine of x is negative 1/2, or cosine of x is negative 1. So ask yourself, where on the unit circle is the cosine of x equal to negative 1/2? So I mean 2 spots. What are they?
2 pi over 3.
Very good. 2 pi over 3 or
4 pi over 3.
4 pi over 3. No, this one also does work, right? Think about where in the unit circle is cosine equal to negative 1. There's only one spot.
It's pi.
At pi. Very good. So therefore, your 3 solutions are these 2 and this one, and you're done. Okay, number 2 says solve. Tangent of x plus 1 times the sine of x plus 1 equals 0. The reason I had those big, huge brackets around there is to show you how to plug it in. Yeah, that's what I said. Plus 1 for the first one, then minus 1 for the second one. All right. It doesn't matter. Doesn't matter. The reason the big brackets are there is to show you how to plug into the calculator. So let's go ahead, see how many solutions we're looking for right off the bat, okay? Oh, and again, we're going from 0 to 2 pi. What?
Your batteries are low in your calculator, just warning you.
Thanks for the heads up. Appreciate that. All right, here we go. Let's plug this in, and here's how you plug this one in. Kind of gnarly. So I'm going to clear this out first. I'm going to go parenthesis, another parenthesis, and then give me tan, and then x, close that, and then plus 1. The x plus 1 is not in its own parentheses. This just says tangent of x plus 1, right? So then I'm going to put another parenthesis. Okay? So this one represents the bracket, then that one represents that one, and then x is in its own, and then this parenthesis represents that one. Times, and then do sine, x, parenthesis, minus 1, and then 2 on the end to close it out.
Doesn't have to change your window.
I do not need to change my window. How come?
Because your window's the same as last time.
Because my window is the same as last time, and I'm still setting it equal to 0. Right?
So what?
It's still set equal to 0, so I'm still curious as to when this crosses the x-axis. Okay? Let's go ahead and read a graph, and you should see this picture.
No, yours are so fast.
Yeah.
So slow.
Okay.
I thought we don't.
So yeah, again, this is just an asymptote. It's actually not part of the graph, and the newer, cooler calculators don't have that, so it's actually truer to the graph. All right? So we're looking for, again, 3 solutions. And we're looking for those 3 solutions on that interval from 0 to 2 pi. There might be others. Yeah, we'll get there. So here we go. How about tangent of x plus 1 times the sine of x minus 1 is equal to 0. We're going to use the same trick by using the zero product property. So this says tangent of x equals negative 1, and this says sine of x equals positive 1. So now you ask yourself the question, when on the unit circle from 0 to 2 pi will the tangent have a value of negative 1? What 2 angles will that be? There's 2 of them out there.
It's 3 pi over 4 and 7 pi over 4.
Very good. Nice job, Griffin. 3 pi over 4 is one of them, and 7 pi over 4 is another one. Then ask yourself on the other one, when on the unit circle from 0 to 2 pi will the sine of x be 1? There's only one spot that's going to happen.
Pi over 2.
Yes, very good. Pi over 2. So therefore, ladies and gentlemen, there are your 3 solutions. All right, so check this one out. This is the hardest one we're going to do today. And there's a reason why this one's more challenging than the others. Anybody see anything different?
2. No.
Cosine sine.
Oh, very good. There are 2 different trig functions. There's cosine and sine all meshed into one, right? Okay, so we're still going to do our same trick. We're going to figure out how many solutions we're looking for. So let's practice plugging this in to see. So y equals, clear all the shenanigans out. So I have 2 cosine x quantity squared plus sine x and then a minus 1. So entering in the calculator, window's still the same because we're still on the 0 to 2 pi. And hit graph. And woo, check it out. Looks like a roller coaster. I like it.
I like why we're finding the solutions again.
What's that?
Why are we finding the solutions again?
That's what we're being asked to do. Yeah. Solve it. So, how many are we looking for, you guys?
3.
I'm looking for 1, 2, 3. Yep, I'm looking for 3 solutions again. Sweet. We're looking for 3 solutions. On the interval from 0 to 2 pi. That's what we're looking for. All right, great. The problem is I have a cosine and then I have a sine. Well, those don't match up. Kind of hard to factor that if they don't match up. Anybody got any good ideas? Something that we could do? We could use an identity set. Very good.
Oh dear.
Yeah. Could we change one of these into the other? Yes, you can.
Cosine squared x.
Cosine squared x minus 1 equals sine squared x.
Good. So let's change cosine squared to 1 minus sine squared. Very good. Plus sine x minus 1 equals 0. Awesome work. Nicely done. All right, let's distribute our 2. I'm going to get 2 minus 2 sine squared x plus sine x minus 1 is 0. Life is good. Negative 2 sine squared x plus a sine x. 2 minus 1. Anybody out there? Very good. Plus a 1 equals 0. And you know what? Before I factor, I like to have positive coefficients in the front. So I'm going to multiply the whole thing by what?
Negative 1.
Very good. 2 sine squared x minus sine x minus 1 equals 0. All right. Now we're in shape. Good shape, by the way. Okay. So how can we factor this? Anybody got any thoughts?
Well, 2 sine x.
Yep. Probably a 2 sine x and a sine x, right? I would assume.
Plus 1, minus 1.
And then Seth says, why don't we try plus 1 and minus 1? Okay. Let's check, is Seth right? Let's do first. Oh, sorry, first I'm going to get what? 2 sine squared x, okay. Outer, what do I get?
2 sine squared x.
Minus 2 sine x, right? Inner, plus a sine x. And then finally a minus 1. Well, that's right. 2 sine squared x minus sine x. And then minus 1 equals 0. That's exactly what we have there. So we must have factored it right. So this is the correct way to factor it. Right? Okay, let me rewrite that down here so we're all on the same page. So we ended up with what? 2 sine x plus 1 times what? Sine x minus 1 equals 0. Again, we'll use the 0 product property. So I'm going to have sine x is equal to negative 1/2, or sine x is equal to 1. This happens when x is equal to 7 pi over 6 and 11 pi over 6. And this happens when x is equal to pi over 2. And those are my 3 solutions.